Alright everybody, so today we're taking a look at simplifying square roots. So how do you simplify a square root? Well, let's take a look at this first example that's written out for us. We started with the number 8, and then what we did was we split this number 8 into two factors, 4 and 2. The reason we split it into 4 and 2 is because if you look at this 4 is this thing that we call a perfect square. Which means that if you square root 4, you would just get out a number, right? What is 4? 4 is technically 2 squared, right? So then we could say the square root will cancel with the square, and then we can just pull that 2 outside of the square root. Notice on the right side, we don't do anything. We can't do anything with 2, with that square root 2, so it just stays in there. Let's take a look at another example. 18. All right. For 18, we split this one into 9 and 2. We split into 9 because, again, 9 is another one of those perfect squares. Specifically, it's 3 times 3, or 3 squared. Again, you can cancel the square with the square root, and then that pulls the 3 out of the square root. Also, the 2, again, will just stay inside that square root the whole time because there's nothing we can do with that 2. One more example here that's already completed for us. We have 75. We decided to split 75 into 25 and 3. 25, again, another one of those perfect squares. So then we take the square root of 25, square and the square root cancel, and then you're just left with 5. Okay? And here we go, number 4. Hopefully we see the pattern going on here. 72, right, this is going to split into 36 and 2. Okay, because 36 times 2 gives us back out 72, which is why we're allowed to split it like that. That square root of 36 is really 6 squared. So the square root and the square cancel, and we're just left with 6 on the outside. That square root of 2 is going to stay on the inside. Alright, let's try one with a couple less steps in it, right? So 54, it's telling us right here that we're going to go 3 and 6. So that means in this square root on the right, we're going to have a 6. And then we need to think about what do we multiply 54 by in order to, or what do we multiply 6 by in order to get 54? Hopefully you said 9. Why does 9 work in this case? 9 is a perfect square. So the square root of 9 is just 3. Okay? All right, number 6. We have 90. So now we need to just take 90, and what we need to do is we need to start dividing it by our perfect squares. Well, what are our perfect squares? 1 is a perfect square, but it's never going to be the biggest perfect square, so we never really check 1. So the next perfect square after 1 is 4. 4 gets built by 2 times 2. After 4, we get 3 times 3, which would be 9. And then we have 4 times 4, which is 16. Continuing, we have 5 times 5, which is 25. And 6 times 6, which would be 36. And you could keep going, right? But here are some of our perfect squares, right, like this. All right, and then we need to find the biggest one that goes into 90. Okay, so in order to do that, we're literally just going to have to start taking 90 and dividing it by some things, right? So 9 definitely divides 90, so let's try that. 90 divided by 9, that gives us 10. So if we go 9 and 10, this perfect square is going to get pulled out, right? The square root of 9 is just 3. Square root 10, the way you know if you picked the correct number or the correct perfect square is to make sure no perfect squares come out of 10. The only perfect square we need to check that comes out of 10 is the only perfect square that are smaller than it. So we would need to check 4, and we would need to check 9. Neither 4 or 9 are evenly divisible or 10 does not evenly divide by 4 or 9, so 10 is just going to stay inside that square root. And then there's our final answer. All right? Number 7, square root of 50. Square root of 50, I'm trying to find perfect square that goes in there. Hopefully you're looking at the list to the left right here and you see that, oh, 25. 25 does indeed divide 50. If we divide 50 by 25, you would get 2. And I'm always putting these in square roots because if you do square root 25 times square root 2, you get the square root of 50. It would just be the square root of 25 times 2, which gives us the square root of 50, which is why we're allowed to split them up like this. That square root of 25 is just going to become 5. We can't pull out another perfect square here, so we just get 5 square root of 2. And last but not least, number 8, you have the square root of 48. So let's think of some perfect squares that might go into 48. 9 is not. Nothing times 9 gives us 48. 4 would come out of there, so let's do that. 48 divided by 4, that would give us 12. So if we did square root 4 and square root 12, could we pull out a perfect square out of 12? Yes, right? You could pull out another 4. You could pull out another square root of 4 there. So we didn't find the biggest perfect square yet. So let's try again. Okay, what comes after 9? 4 times 4 comes after 9, that's 16. So 48 divided by 16. Oh, that gives us 3. Nice. So 16 is evenly divisible. 16 evenly divides 48. And then that would be 3. Square root of 16, we said, is 4 times 4. So the square root of 16 is just 4. I don't write the square root there because the square root of 16 is literally the number 4. And then so our final answer here is 4 square root of 3. Okay, you totally could have done that with 12. Check this out. So if we went square root 48 and we said, oh, 4 divides that, right? You get the square root of 4 and we got the square root of 12. You just have to keep going. You now can pull a perfect square out of here. So you would go square root 4. Square root 4. 4 times 3 gives you 12. So then square root 4 is 2. This square root 4 is also 2. Square root 3 is going to stay. What you do is you multiply the two terms that are outside of square roots. So 2 times 2 would give us 4. And then that square root 3 just gets dropped down. And there we go. We have the same answer. Okay? Just this orange one is a little bit more work than the question on the left, right? Because you had to find perfect squares twice. Okay? So, there's multiple ways to do these simplifying square roots, and it's just whichever way you're finding to be the easiest for you. Rules for simplifying radicals. Find factors where one factor is a perfect square, right? Need help finding factors? Just divide by the perfect squares. So let's take a look at letter A, 96. We need to find a perfect square that divides 96. It's an even number, so I always like just dividing it by 4 to see what happens. 96 divided by 4, that gives us 24. 4 also comes out of 24, so that makes me think, well, if 2 square roots of 4 come out of 96, then 96 must be divisible by 16. So we have square root 16, square root 6, square root 16 gives us 4, so this is 4 square root of 6. All right, letter B, 128. All right, this number is kind of big, so let's use a bigger perfect square to try this one out. I don't know, let's try 36, why not? 128 divided by 36. Nope, doesn't evenly divide 128, so maybe that was 36 is 6 times 6. What about 49? Nope, 49 also does not divide it. Notice how that's 2.6. That's a pretty small number now. So we wouldn't want to go bigger than 49. It's definitely not going to work bigger than 49 because then you're going to get into decimals. So instead, let's go backwards. So we tried 36. So let's try 16 maybe. Oh, 16 and 8. So you know what? I think 64 is the way to go. 8 times 8. There it is. 64. So we go square root 64, square root 2. Square root of 64, right? That's 8 times 8. So this is just going to become 8. And we're left with 8 square root of 2. How we went down on that first one, right? We saw that we could go square root 128 was actually square root of 16 multiplied by the square root of 8. And then you just have to keep going. Square root 8 is square root 4, and square root 2. Square root 4 is just 2. Square root 16 is 4. Outsides multiply, and you get 8. And then that radical 2 drops down. So again, say you found 16 right away. You can use 16 to keep doing the question. All right? Just keep going and finding those perfect squares. All right, letter C. Letter C, square root of 100. Well, 100, if we think about it, is a perfect square, right? So the square root of 100 is just 10. And that could be a good thing to always start on. If you are not sure if a number is a square root, just type in the square root of 100, see what you get, right? You get 10. So we got 10. This negative sign gets dropped down as well. So it becomes negative 10 for our solution. And finally, we have letter D, 28. All right, I know 28 is divisible by, what, 4? So that'd be the square root 4, square root 7. So square root of 4 multiplied by 7 would give us 28. Square root 4 is just 2. Everything outside of a radical has to get multiplied together. So we have 6 is outside of a radical, 2 is outside of a radical, so we get 12 radical 7 as our final answer. Because you just do 6 multiplied by 2, that gives us that 12. All right? And that's how you simplify radicals. If you guys have any questions, please let me know. Message me on Canvas. I'd love to talk. All right? Have a great day.